Hello, here in this video we're going to be looking at the zero exponent rule as well as the negative exponent rule. So we'll be using these videos as a source of review that we can look at before we have quizzes or tests on these topics. So let's begin. Any base to the zero power is equal to 1. This is the zero exponent rule. Now you may be asking, what is a base and what is a power? Well, we know that the base, just like the base of a building or any kind of foundation, that's going to be our number, or it could be a variable that's going to be down low. And when it says a power, that is the same thing as the exponent. And the exponent is always that little number that you see up top. Alright, so anytime we have a base, so it can be a number, it can be a variable, and it's to the exponent, and when that exponent is a 0, we're always going to be equal to 1. So I'll show us some examples of that and see what it looks like. Say, for example, I just have a number. So I have 4 to the 0 power. We have a base to the 0 power, so it is always equal to 1. Say I have a variable. Say we've got an x. We've got an x to the 0 power. What's it going to be equal to? Well, we have a base to the 0 power, so it is equal to 1. Alright, so no matter what our base is, doesn't matter how large it is, we could have a base of 1,000. And if it's to the 0 power, it's going to be equal to 1. Okay, so that's how it looks when we just have one base with that 0 exponent. But what happens when we have some sort of combination? Say we have a multi-term expression here, something like this. Say we have a 5, and then we have an x to the 0 power. Alright, so notice how the rule says any base to the 0 power, only that term will turn to 1. So for us here, the only base that has a 0 exponent is going to be this x here. Alright, so only this x to the 0 power is going to turn into 1. So since this original expression was 5 times x to the 0 power, when we turn that x to the 0 power into a 1, all we really have here is 5 times 1. So our final answer will be a 5. Okay? So now keep in mind that this whole thing is not 1. Only the base that has the 0 power will turn into a 1. Now that's something that's important to keep in mind with exponents. Only the base gets the effect of the exponent. Okay? So now let's look at the negative exponent rule. It's not quite as straightforward and simple as the zero exponent rule, but that's okay. So the negative exponent rule says any base, so we've already reviewed what that is, with a negative exponent must switch spots in the fraction, and that's called taking the reciprocal. And the exponent must become positive. Okay? So let's see some examples of what this could look like here for us. Alright, so say I just have a base. What if my base is a y? And I've got a y to the negative 2 power. That negative exponent tells me I'm going to need to switch spots in the fraction. Now right now, we know that this y is our numerator. It's on top of our fraction, and we have an invisible 1 down here. Okay, and that negative exponent tells me I'm going to have to take this base, this negative exponent, switch its spots in the fraction. So our y is now going to be on the bottom, is going to be our denominator, and its exponent will turn positive. And keep in mind, anytime we do not have something in our numerator, there is just a 1 there. Okay? So negative exponents tell me to take my base that has that negative exponent, switch its spots in the fraction, and turn it positive. Okay? So let's look at a couple more of these examples here too. Say we have one like this. Say we have a 3 up top, and then down low we have an x to the negative 2 power. So let's think about our rule. It says any base that has a negative exponent must switch spots in the fraction. The only base I see with a negative exponent is this x. So it will switch spots in the fraction, and the exponent will become positive. Now since there's already a 3 in our numerator, it will just stay right where it's at, and it will be joined by our x now with a positive 2 exponent. Now you may express your answer as over 1, but you don't have to. Okay? So if you want to express it over 1 like that, you can, but you don't have to. Okay, you can just leave it as this. And it is implied that this is just over a 1. Okay? So as terms are moving around, they will just join whatever is already there. And I'll show us another example of this as well. Okay? So say we have something like this. Say we have a 4x negative 2, and down on the bottom we just have v to the 4th power. So I'm going to look for negative exponents. The only negative exponent I see is with this x. So we will switch spots in the fraction and turn positive. But notice how the 4 and the v to the 4th power do not have any negative exponents with them. They will stay right where they are. So I'll have my 4 up top, my v to the 4th down low, and it will be joined by my x squared. Right, and this will be my final answer. Okay, so we'll look at one problem that kind of puts the 0 exponent rule, this negative exponent rule, all together, and that'll conclude our review here. So let me get one prepared for us here. Let's say we see something like this. And I'll even toss in a chance to get some number practice in. Let's say we have a 3 squared. Okay, then we have an x negative 2, a v to the 0 power, and all of this is over a y to the negative 3. So let's take this one piece at a time here and see if we can't compose our answer. Now when I look at this 3 squared, we learned how to do this on our calculators. We also know how to do it with our minds. This is 3 times 3. That will give me a 9 up here in our numerator, because there's no negative exponent to tell me to take it to the denominator. When I look at this x term here, it has a negative exponent. It's going to have to switch spots in the fraction, so it was on the numerator, now it's on the denominator with a positive exponent. This v to the 0 power, it's really just equal to a 1. So if I wanted to put 9 times 1 here, I could, but we know that 9 times 1 is just a 9. So essentially that v to the 0 power goes away. Now the only thing we haven't addressed yet is this y to the negative 3 power. Right? And since it has a negative exponent, you'll have to switch spots in the fraction. It was in the denominator, now it is in the numerator with a positive exponent. Alright, so this problem here kind of put all the rules together and let us get some experience seeing how all this works.